Hello children, welcome back to my channel. Now I am dealing with 7th class maths. A new chapter I am starting, that is quadrilaterals. So here I have written about the definition and about the elements of quadrilateral. I will explain one by one. Please note it down. The first one is about the definition of a quadrilateral. What is a quadrilateral? A closed figure with four sides, four angles, and four vertices is called a quadrilateral. It is a closed figure, children. What is the difference between closed figure and open figure? I'll write it here, children. Figures are of two types. One is open. Open figure means it is like this. There is a gap. These are called open figures. And a closed figure means like this, which is there is no gap between the sides. All are closed. So a closed figure which contains four sides, four angles, and four vertices. See here. 1, 2, 3, 4 sides are there. Four angles, and these are all four angles and four vertices are there. This is the definition of closed figure. And what are the elements of closed figure? Elements means what does it contains? Like in a triangle, you have learnt about what are the elements of a triangle. It has three sides, three vertices, three angles. Similarly here, it has got sides. How many? It has four sides. So in the example, the four sides are AB, BC, CD and DA. And it has got four vertices. What are the A, B, C, D in the example figure? These are the vertices. So according to the figure and its names, these values, these letters will change. And angles, it has got four angles. First one angle A, B, C. So you know pretty well when you are writing angles, you can write the name of an angle in two different ways. In fact, you have some more ways also, but only I'm now speaking with the two different ways. One is if I write angle ABC, the center letter what it is there, with that also you can name it. That means angle ABC is named as angle B. Angle ABC can be named as angle B. Angle BCD named as angle C. Angle C. Middle one is C. So angle C. Angle CDA is named as angle D. Then angle DAB. Angle DAB can also be named as angle A. So these are the four angles, and it has got a vertices I have told, four angles I have told. Now what about the diagonals? Actually, what is the meaning of diagonal? That first you should know. Diagonal definition is lines joining opposite vertices of a quadrilateral. See, A is there, its opposite vertex is C. B is there, its opposite vertex is D. Vertex is singular, vertices is plural. So, if you join the line of opposite vertices, the lines are called, line segments are called diagonals. So, in the example, AC is one diagonal and BD is another diagonal. Please note it down, children. These are the notes for this quadrilaterals. Now, children, the next one is adjacent sides. Actually, what is the meaning of adjacent? Adjacent means the immediate next is called adjacent side. So, the definition of adjacent sides is two sides of a quadrilateral which have a common vertex. They are called as adjacent sides. Both should have a common vertex. See, in the example AB, BC. These two sides are having a common vertex B. So B is the common vertex. Then BCCD is having C as the common vertex. Then CDDA is having D as the common vertex, and DAAB which is having A as the common vertex. So these are all about adjacent sides. Next, adjacent angles. What are adjacent angles? Definition is two angles of a quadrilateral having common side. They are called as adjacent angles. So first set is angle ABC and angle BCD. In this, see, BC is repeating two times, ABC, BCD. So common side BC is the common side. Next, angle BCD, angle CDA. Both of them are having CD as the common side. Next, angle CDA, angle CDA, angle DAB. DA is the common side. Next, angle DAB, angle ABC. AB is the common side. They are called as adjacent angles, adjacent sides, adjacent angles. This is the definition, and this I have given as an example from the figure which I have drawn. Please note it down, children. Now, the next element is opposite sides. What are opposite sides? In the earlier case, we have done adjacent sides. Now, opposite sides. What are opposite sides? The two sides of a quadrilateral which do not have a common vertex. Adjacent sides, they have a common vertex, but opposite sides, they do not have a common vertex, are called opposite sides. Example is AB and CD. These two sides are not having any common vertex. Similarly, BC and AD, these are also two sides which are not having opposite common vertex. So these are called opposite sides. Then opposite angles. The two angles of a quadrilateral which do not have a common side. Adjacent means they have a common side. Opposite angles means adjacent angles means they have a common side. Opposite angles, they do not have a common side. See, first one, angle DAB and angle BCD. They are not having any common side. Similarly, angle ABC, angle CDA, they also are not having any common side. So they are all called opposite angles. So opposite sides and opposite angles. Please write down. Now, children, the next one is different types of quadrilaterals. Of course, basing on the line segment, two types are given here. The other types we are going to discuss afterwards. But convex quadrilateral, concave quadrilateral. So, what is the difference between these two? Let us discuss about it. A quadrilateral in which the line segment formed by joining any two interior points also lie inside the quadrilateral is called a convex quadrilateral. Means what? You take any 2 points. Here you have taken. You can take here or here, anywhere. 2 points if you take and join them, you will be getting line segment. See, I have taken P here, Q here, I have joined. I have got a PQ line segment. So like this, any two interior points, remember children, only interior points. Any two interior points if you join, the line segment that is formed, if it also lies inside the given quadrilateral, then that quadrilateral is called convex quadrilateral. Next, concave quadrilateral, opposite to it, means see, this is also a quadrilateral, see A, B, C, D. A, B, C, D. Four sides are there, four angles are there, four vertices are there. So it is also quadrilateral. But what is concave quadrilateral means? A quadrilateral in which the line segment formed by joining any two interior points do not lie inside the quadrilateral. It is called concave quadrilateral. Let me put inverted commas here. So this is the underlined one. Concave quadrilateral. So that means what, children? I have taken point P and Q. But when I have joined PQ, see, some part is lying outside the quadrilateral. So that means what? See, here if I take, of course, they lie inside. But we should think about each and every nook and corner of the quadrilateral. But there are some places where when you join 2 points, see, point P is inside the quadrilateral only, point Q also is inside, interior points they are. But when I joined, I got a line segment, a part of the line segment is lying outside. But here it is not like this. So this kind of quadrilaterals are called concave quadrilaterals. A quadrilaterals in which the line segment formed by joining any two interior points do not lie inside the quadrilateral. Then that is called as concave quadrilateral. These two names you should be perfect with it, children. Please note it down. Now the next part is, children, we need to prove that sum of the angles of a quadrilateral is 360 degrees. This you have to prove. Sum of the angles of a quadrilateral is 360 degrees. See, children, let me take A, B, C, D. So what is given to us? They have given A, B, C, D is a quadrilateral. This is given to us. Now, what is RTP? RTP means required to prove. We have to prove that sum of angles of ABCD is equal to 360 degrees. This you have to prove. There is a construction, children. What is this construction? You have to join AC. Join AC. This is construction. Now let us see the proof. Proof is sum of angles of ABCD is equal to sum of angles of triangle ABC plus sum of angles of triangle ADC, isn't it? Because you have joined this, you are getting two triangles. One is triangle ABC and another one is triangle ACD or ADC. Now, ABCD quadrilateral sum of the angles is nothing but sum of the angles of triangle ABC plus sum of the angles of triangle ADC. Sum of the angles of triangle ABC is 180 degrees. We know that in triangles the sum of the three angles is 180 degrees plus another triangle also is 180 degrees. That is equal to 360 degrees. Therefore, we will say that sum of the angles of ABCD is equal to 360 degrees. Hence, proved. This is the proof of this statement, children. What is the statement? Sum of the angles of a quadrilateral is 360. This you have to prove. Now, ABCD is the quadrilateral given. What is given? ABCD is a quadrilateral. What is RTP? RTP means required to prove. What is it? Sum of angles of this ABCD is 360 degrees. There is a construction. Construction means the one which you need to do so that you can prove the given statement. That is what AC you have to join. Always construction should be drawn in broken line. Now let us see the proof. The proof is sum of angles of A, B, C, D is nothing but sum of angles of angle of triangle ABC. See, triangle ABC, this triangle angles sum plus sum of angles of triangle ADC in this also. Sum of the angles of these two. Now you know that sum of the triangles of a triangle is 180. So this sum is 180 plus this angle sum is 180, total 360. So sum of the angles of ABCD is 360 degrees. This is how you can prove this, children. Please note it down. With this, I am going to conclude my topic today, children. In the next class, we'll be doing the next part.